That the cause, and in this video we'll be looking at nitrogen 2 oxide. Nitrogen 2 oxide is the second oxide of nitrogen, and the formula is NO. It's a colorless gas that the smell has not been detected. It was discovered by Henry Cavendish in 1770 as one of the product formed during an electric spark, or when thunder and lightning strike rather. So NO is a product that is formed by passing strong electric voltage through air. It has great affinity for oxygen. It combines with oxygen anywhere to form brown nitrogen 4 oxide. Remember, it's colorless, but it quickly reacts with oxygen to form brown nitrogen 4 oxide. How do we prepare nitrogen 2 oxide in the laboratory? Number one, it can be prepared in the laboratory by the action of dilute HNO3. Actually, it's 50% HNO3, is a dilute form of HNO3 reacting with copper turnings. That is how you produce NO in the laboratory. As you can see, the equation of the reaction, you can see that 3Cu reacts with 8HNO3 to give us copper 2 rather than nitrate 5 plus water plus NO. It's very, very important to know that it is 50% HNO3 that you normally use to produce NO, because you can also produce NO2, but if the HNO3 is concentrated, so it has to be very, very clear. The equation for using conc HNO3 is below, and you see that it does not produce NO, but instead produces NO2. Alright, so this is the diagram setup for producing NO in the laboratory. What are the physical properties of nitrogen 2 oxide? Number one, it's a colorless poisonous gas. The smell is unknown as it immediately changes to NO2 when it's exposed to air. When it changes to NO2, it turns brown. It's almost insoluble in water. It's slightly slightly denser than air, and it is neutral to litmus paper. What are the chemical properties of nitrogen 2 oxide? That's nitrogen 2, not nitrogen dioxide, nitrogen monoxide, nitrogen 2 oxide. It combines readily with oxygen at room temperature. We have said that to give us brown films of nitrogen 4 oxide. It quickly, rapidly, spontaneously reacts with oxygen to give us nitrogen 4 oxide. So, and it can decompose if you heat it to a temperature of 1000 degrees Celsius. It can decompose into nitrogen and oxygen gas. Hence, it takes a substance that can burn with that temperature or above it to be able to continue burning inside NO. Because to burn inside NO, you must achieve the composition of the compound, right, into oxygen gas, and continue to use that oxygen gas to to continue to burn, right? So if you are not burning with sufficient heat to decompose the NO, you cannot continue to burn in NO. So compound like burning magnesium, burning phosphorus, burning lead can produce this kind of energy that will decompose NO to form oxygen, so they continue to burn in NO. But any other substance like burning sulfur or any other burning splinter that cannot produce such amount of temperature cannot continue to burn inside NO. So NO will extinguish them, but will support the combustion of brightly glowing substance like magnesium, phosphorus, and lead. So it reduces hot metals into nitrogen. You can see that the magnesium burns with intense white flame, as you can see in the script in the screen that you are seeing now. If you put that burning magnesium inside a gas jar of NO, it will reduce NO to nitrogen gas. Yes, it also reacts with freshly prepared iron 2 tetrasulfate 6 solution to form a dark brown solution of FeSO4.NO, an addition compound which can decompose again when heated. This is the major test for detecting the presence of NO, because NO also have affinity for FeSO4, and when they combine they form brown compound FeSO4.NO. As you can see here, this is the basis of brown ring test. When we are testing for the presence of NO3 minus, we still get there. So NO have affinity for FeSO4 and combine with it to form a brown compound anywhere they meet each other. So I've already said that that's the formula. FeSO4 plus NO will give you FeSO4.NO. Anywhere there is NO gas, if you bring FeSO4 near that place, FeSO4 solution will turn brown. That brown compound is an addition compound FeSO4.NO. What's the test for nitrogen 2 oxide? Two tests. Number one, since we know that whenever you open the gas jar of that compound, it spontaneously reacts with air, oxygen, and turn to NO2. And NO2 is brown in color. So if you are suspecting a gas to be NO, just go ahead. The gas must be colorless inside the gas jar because that's the color of NO. So just go ahead and open it. If you open the gas jar and the colorless gas is turning brown as it's coming out of the gas jar, then that colorless gas is NO, and the brown gas coming out is NO2, and that brown vapor is formed because NO has combined reacts with oxygen in the air. So that is why you have that color brown, NO2. So it's due to its affinity with oxygen. So the test is to remove the stopper of the gas jar. If the gas turns reddish brown on exposure to air, the gas is probably, most likely, nitrogen 2 oxide. How do you now confirm? Confirmatory test for the presence of NO. You are going to use a freshly prepared iron 2 tetrasulfate solution and put it into the gas jar of that unknown gas. If the solution turns brown, then the gas is undoubtedly NO, because NO is a compound that always forms brown addition compound with freshly prepared iron 2 tetrasulfate 6 solution. So that will be the end of our video on nitrogen 2 oxide. In the next video, I'll be talking about nitrogen 4 oxide. God bless you. Amen.